Hello, this is my first YouTube video and today we are going to discuss about some inclined plane problems and the force and acceleration on an inclined plane. Let us start. Let's suppose that this is an inclined plane. It is inclined at an angle of theta. And then let's suppose that a block of mass m is kept on this place. Like this. It has a mass m. So now, if this angle is theta, then over here the mg force which is going to pull this down, mg, and the reaction force which will be perpendicular to the surface in contact will also make an angle of theta. So now let's find out what will be going to be the magnitude of this. So let's find out. On the in the hypotenuse it is mg. So cos of theta equals adjacent by mg. Therefore, force of adjacent will be mg into cos of theta. Once we get this, so as we know the triangular rule of vector addition, the resultant force will be this one. So this is the hypotenuse, this is the perpendicular, and this is what we are going to call as breadth or the adjacent, you may say. So let's start. This is the length of the perpendicular. So this one will be, let's name it as b, will be square root of hypotenuse square minus perpendicular square. So now if I do this, this will come up as m square g square minus m square g square cos square theta. M square g square will be common, square root 1 minus cos square theta. Basic algebra is coming as mg, m into g, and square root of 1 minus cos square theta. As we know, a very popular trigonometric identity as sin square theta plus cos square theta equals 1. So sin square theta will be 1 minus cos square theta. If I square root both these sides, then sin theta will be equal to square root of 1 minus cos square theta. So I can also write it as m into g sin theta, or I can leave it as like this. So now the net acceleration of the block, irrespective of friction, will be m into g. I am keeping it as the initial one, 1 minus cos square theta divided by m. So any block which is kept at an inclined plane, always the acceleration, the net force, will be this thing. So now it's on you that you put at any values of this particular thing, and we'll discuss the next thing in the next lecture. Thank you.